Hello friends, welcome to a new video where we'll be discussing detecting a cycle in the undirected graph. So we are given a graph here with 4 nodes 0, 1, 2, 3, and we will be traversing this graph using DFS method. If you don't know DFS, then you can visit my previous video. So when we use DFS, it means we'll be hopping from one node to other based on its adjacency list. So we can start traversing this graph from 0, and we'll go first to this node. From here we'll jump to second node, third node, and when we reach here we'll be able to we'll realize that since this was already visited, so it means a cycle exists in this graph. But however, we need to ensure that we also avoid any false detection of cycle in a graph. For example, when we are at this node, when we try to check the adjacent nodes of it, whether they are visited or not, and since we'll realize that we had already visited 0, we may falsely detect a cycle. So to avoid that, we need to maintain a parent-child relationship. First, let us take a look at it, and then step by step we'll iterate and understand how to detect a cycle in the graph. So 0 can be considered as parent for 1, because from 0 we are going to go to the next node, which is 1. For 1, 1 will act as a parent to 2, okay, and 2 will be its child. From 2 we'll hop on to 3, since 2 is introducing us to 3, so 2 will be the parent and 3 will be its child. And when we reach at 3, since all of them have already been visited, so in this at this point of time, since 3 will realize that for this first node was already visited, and since it is also not the parent of 3, so it means the cycle exists. So step by step, using this code, we'll try to understand. So initially we'll be maintaining a Boolean array uh, to just record whether a node is visited or not. So initially all of the nodes we have not yet visited, so it will be false. Then we'll start from 0, and we'll mark this as visited or true, and from there we'll check for the any of the adjacent node to it, which will be 1, and we'll be marking it as true as well. So initially our Boolean array for visited nodes will look something like this when we are at this node. Then we hop on to the next node, that is 1. So at 1, again we'll check which of its adjacent nodes are not yet visited. So since 0 is visited, we don't need to consider it. And also although it is visited, but since 0 itself is the parent of 1, so we also cannot treat that a cycle exists. So we have to move on to the other node which is not yet visited. So we'll move on to 2 from here, and we'll be marking 2 as true, because after reaching here we have hopped on to node 2. So far we have visited 3 nodes now, 0, 1 and 2. Then at this step, at node 2, we'll again check which of the nodes are not yet visited. So since there are only 2 adjacent nodes to 2, and out of which 1 was already visited and 1 being parent of 2, we cannot conclude that it has a cycle. So we'll consider 3, which is not yet visited, and we'll hop on to 3 and mark it as true. So now so far we have visited all of the nodes present in this graph. So by the time we reach 3, now we'll again check if any of its adjacent nodes are not yet visited. So we'll realize that both 1 and 2 are its adjacent nodes, and since both of them have been visited, so if we consider 1, then if we consider 1, then 1 is not the parent of 3, right? So it means definitely a cycle exists, although it's visited and it's so far it's not the parent. But however, for 2, from whenever we are at 3, if we try to check for node 2, it will be visited, but it is the parent of node 3. So it means this cannot be tell us that a cycle exists in the graph. So finally we can just return a true value. So from code perspective, every time we are marking the nodes as true, and then we are just extracting the adjacent nodes whichever are not yet visited, and then we'll recursively keep calling as long as that node is not visited, and we'll traverse the entire graph. Hope you have understood the logic, and for practicing this I have provided the code link in the description below. You can practice it on any of the online compilers. Thanks for watching the video.